Hi, my name is Julia Silge, and I'm a data scientist and software engineer at RStudio. And today, in this screencast, we're going to use this week's Tidy Tuesday dataset on bird baths in Australia. And we're going to train a model to predict whether we see a bird at a bird bath, a bird of a certain kind, at a bird bath, and we're going to control for whether the bird bath is urban or rural. This screencast is going to be a good one if you are more getting started with tidy models, if you are maybe even getting started with modeling in general, because we're going to focus on some kind of core skills. How do you combine a model specification, like you've chosen some kind of model to use, together with a feature engineering recipe, as we call it, like a set of pre-processing instructions, and maybe how can we build up the data pre-processing recipe to do more if we want to do. Then we'll predict, we'll show how to evaluate the model, and how to predict on new data. So let's learn about birds. Okay, let's learn about bird baths in Australia. So this is this week's Tidy Tuesday dataset, and it is pretty fun, I think. Pretty interesting. So let's take a look at it. We have got quite a bit of data here, and if we see what variables we have, this survey, this was like citizen science data on what kind of birds were observed in these different bird baths. Data was taken in a couple different years, in urban and rural situations, in different regions in Australia, and then there's lots of different bird types that were observed here. So let's look at a couple things. So how many bird baths that are urban and rural do we have? Okay, so these NAs, I think, are summary rows. Yes, they are. And this might be helpful. We can use it to find the most important birds, because there are a ton of different kinds of birds. And for this modeling that we're going to do, I don't think we're going to be able to handle all the birds. So we're just going to be able to look at some of them. So let's look at, let's do a range minus bird count like this. So these are the birds there are the most of in this data set. And these NA rows, if you go back and look at the Excel file, these are like summary rows here. So if we take, by bird count, we take the top, we take a slice of the top, let's try like 15 rows. These are the birds that are in this data set the most. And if we pull out the bird type, then we just have a vector of these birds. So let's call this top birds. These are the top Australian birds that we can use here. So now that we have this, let's do just a little bit of some exploratory data analysis. So now let's do the opposite. We want not those summary rows from the Excel file that this data was created from. Oh yeah, let's also do bird type in bird baths. Bird type in our top birds vector that we have. And then let's do something, let's see, I'm interested in differences by the urban and rural situations, the bird baths that were in cities versus more rural areas, and then by these different bird types here. And then let's summarize bird count. You know what, before we do that, do we count them up? I don't think so, because I think the way this is, so notice here we've got lots of zeros, lots and lots of zeros. Lots of zeros, and then there's a 1 when they see a bird. I think the count is only ever 1. Let's look at this. So if we pull out bird count and then we do summary, yeah, it's only either 0 or 1, and it's mostly zeros. Most of the time we don't see any birds or of those specific kinds of birds. So if we say mean bird count, if we did something like this, what this would say, you know what, I'm gonna do groups drop like that. So this is saying in rural, over the bird baths where this citizen science survey was done, in rural bird baths, the probability, I think that probability that people saw an Australian magpie was about 25% of over all the times, places and locations and bird baths that they looked. It's much lower for the crested pigeon, and we've got a little bit higher for the eastern spinebill. So we've got 0 if there was no bird there, and it looks like there was a 1 if there was a bird there. So let's call this bird parsed, and then let's make a little plot with this. So let's say bird parsed. So let's put bird count here, which remember this is like a mean, like a proportion on the x-axis, bird type on the y-axis, and then let's put points here. Let's make them big. Let's use the aesthetic of color to apply to that urban rural, like so. Let's do this. So this is a beginning of a plot that we have here. And let's kind of iterate on this a little bit. So on that x-axis, this, so we remember, like, this is a percent here. And we can do things to the labels like the x, this is the probability that people saw bird. And we can take off these other ones like that. Okay. And notice that, these things switch back and forth. But like the superb fairy wren, that is a lovely name. I am in love with that bird's name. It was much more likely to be seen in rural and urban areas, whereas the noisy miner, again, that's an amazing name, was much more likely to be seen in urban than rural. We can kind of emphasize that a little bit by putting some segments between it. I think this will be the best way to do it. So let's, I'm gonna make these a little see-through. I'm gonna make these gray. I'm gonna make these a little bit thick. But I'm gonna use different data here to like draw a line from one line to the other. So the data that's being passed into ggplot right now looks like this, but the data to draw a line from one point to the other will actually need to have different ends, different x, like x and x end. So I'm going to use pivot wider. So I'll say names from urban, rural, and values from bird count. So this is the data that we'll need to go here. So let's say data equals this, like so. And then we will need a different aesthetic for this geom segment. So x will equal, I think it doesn't matter what order it goes in. We can say rural x and end equals urban. And then the Y, these are the same. Y equals bird type Y and equals bird type, like that. So what we're saying is draw a line from this point to this point, from this point to this point, and so on. So let's see if this works. It does, but it would help if I put the rest of my plot on. Okay, all right. I like this plot. This is kind of like a lollipop plot. I think people would call it like that. And you can see that the colors, by flipping back and forth, they tell us, is this a bird that you see more in cities or more in rural areas? So, you know, Lewin's honeyeater and gray fantail and eastern spinebill, these are all birds that we see more in rural areas. The rainbow lorikeet and the noisy miner and the pied currawong are birds that we see more in urban areas. So this is the kind of information that we're going to use in our modeling. Let's create a little data frame we're going to use for modeling. So it's basically going to be this, like so. So let's see what we have if we do that. Then I am going to change that bird count data. I'm going to say if else, if bird count is equal to 0, is greater than 0, I'm going to say bird, otherwise it's no bird. And then I'm going to change these things from characters to factors. In modeling, we often really do want factors, not character things. All right, so this is going to be our data set that we're going to use for modeling. And so our idea is we're going to model bird count, were there birds or no birds, based on some of these other characteristics. Actually, well, we're going to really dial it down. We're only going to use the stuff in that plot we just saw, urban versus rural and bird type, and see what we can learn there. So like I said in the intro, this is a good video if you're just getting started with tidy models. And we're going to really step through things from the beginning. So the first thing that when we deal with modeling is we need to think about spending our data budget. So we have quite a bit of data here. So the first thing we're going to do is we're going to split our data into testing and training. So by using the function initial split, I create what is called a split object. So it has an analysis section, that's like training, an assessment section, that's like testing, and then this total is how much data is there all together here. If I call the training function on the bird split, that gets out the training part. Let's assign that to bird train. If I call the testing function on the split, that gets me the testing data. So let's run that and we can see what it looks like. Bird test. Notice it looks a lot like this data we started with, but there's less of it because we have split it into 3/4 of the data going into training and 1/4 of the data going into testing. So that is the first bit of spending our data budget. The next part of setting our data budget is we're going to create some resampling folds. This is big data, so I'm going to do stratified resampling. I'm going to use v-fold cross-validation. I'm just going to do the default, which is sensible default in a situation like this, 10-fold cross-validation. Let's call this bird folds, like so. All right. So now what this does, what the resampling does, is it takes the training set and it creates 10 simulated data sets created by cross-validation from the training set that we can use to train different models and compare them and see how they're doing, and without ever touching our testing data, which is a precious, precious resource. Okay, so this part here we think about as spending our data budget. Now it's time for us to talk about the setting of our actual model. So I am going to use just a basic logistic regression model here. We recently changed the input for a tidy model so that, or the interface for tidy models, that this is actually all you have to do now for logistic regression, which is kind of nice. So this is equivalent to a GLM binomial, family equals binomial logistic regression model. And now we can start thinking about what do we want to do for feature engineering here. So I'm going to use a recipe to set up the feature engineering for this. I'm going to start with something simple, and then I'll be able to build it up. So I'm going to declare my outcome and my features, my predictors: urban, rural, bird type, and then I'm going to say what data am I using here. So this recipe right here, what it does is it says, hey, I'm about to do some feature engineering. Here's what my outcome is. Here are what my two features are, and here is what my data looks like. So I am setting up my data, my feature engineering or my data preprocessing. A logistic regression model needs doesn't want us to have these factors, but instead probably should have our data in a numeric form so it can do math on it. So we would probably want to change these to dummy or indicator variables. So here, so we can change everything that is nominal, which is our urban, rural, and our bird type, and then change it to dummy or indicator variables. So let's call this recipe basic, like so. So let's run both of these things. So now we have our two pieces that we need for a model, our way to estimate our model and our feature engineering recipe. Right now, neither one of these have been run. None of these have been estimated in any way. So we could do that manually, but instead let's put them together in what's called a workflow. So workflow is a convenient way to put together a feature engineering recipe or formula together with a model specification like to connect them together as if they're Lego blocks so that they're easier for you to carry around. So if we do this, now we have something called Workflow Basic that has these things together. We have a recipe, we have a model, and it tells us a little bit about what is here. So we could fit this model, this workflow, one time to our training data, but this is where those resamples come in. We are going to fit it instead to those 10 resamples. And the reason we're going to do that here is so that we can get a better estimate of how this model is going to perform. Instead of fitting it one time to the training data and then having to immediately go to the testing data for any kind of comparisons, if we fit it 10 times to those resampled folds, we are able to get statistics about how the model is doing, and then we can compare, this model to maybe the next one we're going to try. Let me add one more thing here, just a control function, control resamples, so that I can say save pred equals true. And this way, I can do a little bit more with my results now. So now what we have here, this looks a lot like our resampling splits that we had at the beginning. We have 10 cross-validation resamples. But now we have metrics for each time that we fit this workflow up here to this data. So the data, that model was fit to this data and then evaluated on this data. Fit to this data, evaluated on this data, and so forth and so on. And then these predictions in this column over here, you can kind of see it. Let me move this over so you can see it a little bit better. Notice that it has the same number of predictions as are in the assessment set. So we are making predictions not on the data that was fit, we are making predictions on the data that was held out of each of these sets. So that was what goes on when we use resampling. It's a really good way to be able to get more accurate estimates of how models are going to perform. Okay, so let's look at, there's a function called augment, where we can, what augment will do is it'll take these, it'll take like the assessment sets here and take all the data that we have about it and then add on a prediction. So it's going to say, you know, if we know bird type and bioregions and survey year and all that information we had that weren't even predictors, let's add for those, each of those rows, let us make a prediction. So we have the true value here, and then the predicted probability of seeing a bird, predicted probability of not seeing a bird, and predicted class given a default cutoff. So augment is really useful. You know, you can just imagine all the different kinds of analysis you could do from here. A sort of basic one would be to make an ROC curve here. So we say the column with the true value, the column with the predicted value here, and we can, you know, you can compute that, or you can then make a plot. And we can look at what we get there. Wow, that, not impressive, right? You know, the data that we're working with here is, I'm trying to predict if you're going to see a bird or not just based on 2 variables, right? So, you know, maybe we don't expect super results, but just notice how this is barely better than guessing, right? We're very close to this dash middle line here. It is not doing super great. But we can see this, you know, we got to the result pretty quickly by, you know, looking at our results here, by looking at our results. So that is at least good to be able to get to that information easily. I think it's time for us to try to do at least a little bit better, even with this data that we had. If you remember this plot that we made, is it the last one? Yeah, we know it's not linear, right? Like it's not like, oh yeah, let's make it linear with rural and urban, and it's not linear and independent, right? Like we know that there are interactions between the birds and whether it's rural and urban, right? For some birds we see more in rural areas, and some birds we see urban. So we at the very, very least need to add some interaction terms. This is, you know, we're just kind of walking through some of the basic things that we can do here with recipes to give you a starting place so that we can learn from here and keep moving forward. So we can take our basic recipe and we can continue to add steps. So we can add interactions here. The way that we add interactions between these things is that so if we have this basic recipe that we made, if we were to prep it here, we made dummy variables from urban, rural, and bird type. What prep means, prep is the analogy for a feature engineering recipe to fit as a model. So prep is to a recipe as fit is to a model, where you want to estimate for this feature engineering recipe, what are the quantities that we need to be able to apply this to new data. So, you know, before we said, oh, all nominal predictors, we don't really know what's in there. And now we do after we call prep. We know that we know what's in this data. So if we want to make if we want to say, hey, I would like to include interaction terms in my feature engineering recipe. The way that we do that is that we do it with a anonymous function kind of situation here, and we can do it with the names of variables. In this case, we're creating new variables. Like if I were to keep going here and use not just fitting or prepping, but also applying to new data, which is like predict, but in a recipe it is bake. You'd see we have all these new variables: urban, rural, urban, bird type, noisy miner, bird type, red brown finch, bird type, satin bowerbird. And these are all zeros and ones because these are dummy or indicator variables. So if I want to make interactions, set up interactions between all of these, I'll say starts with urban, rural, interacting with starts with bird type here. So the reason why this is nice is because I can just start with my initial variables. I don't need to know, what happens. And let's say I do, other stuff in between where I filter stuff out or change levels, like more complex factor handling. I can just say like, okay, well, what do you have right now? What do you have right now? Let me deal with that. So this is a really fluent way to be able to make a recipe that works well. So let's call this recipe interact like this. And then we are going to make a workflow interact and workflow, and let's put the recipe interact and that same GLM spec. And I'm going to do the same thing. Let's make our results fit resamples. So I'm going to fit to the resamples this workflow to the folds. And I'm going to say control equals control preds again. Okay, so I'm doing the same thing. I added a step to my feature engineering recipe. Instead of just having those things all independent of each other, I now have added interactions. I made a new workflow that has the same model, but new feature engineering recipe, and I'm fitting those to my resamples. Notice I'm not just fitting to my training data, I'm fitting to my resample so I can have a better estimate of what how this model will do. And that, looks way better. Look how much better that looks. We can measure this with ROC. We can measure this numerically with area under the curve of the ROC curve, but we can see this visually just in a really big way, right? So this model I think is much better. So we could keep going using feature engineering, adding other variables to make this better, but I don't want to keep going forever. So let's just say we just wanted to use those two features for making our model, and so this was good enough for us. Let's say we wanted to keep going here now. So what we could do now is we could fit, instead of fit resamples, we could fit now our workflow with interaction terms to the training data, and let's call this bird fit like this. So we have now fit our workflow to our training data, and now we can do lots of things with this fit model, this fitted workflow. It has a fitted preprocessor, an estimated or prepped preprocessor. It has a fitted model, and now we can do all kinds of things. We can predict with this bird fit on the test data, bird test like that. No bird, no bird, no bird. This model might not be super well calibrated. It may be predicting all no bird because the probability of seeing a bird is pretty low. We can augment like we did before. Let's actually make some new bird data. So let's, instead of evaluating the model on the test data, let's evaluate the model on new data. So let's make a tibble. Let's see, bird type bird type, let's say those top birds, and then let's use crossing from tidyr. Let's say urban, rural, and let's put those levels that we had in the real data, urban, rural, like that. So this new bird data, this has those birds we're interested in that we put in the model, and then urban, rural. So these are our inputs, right? So we can do a couple things. We can say augment bird fit with new bird data, like this. So it's saying, if you have these things, what do you predict? What's the probability of seeing a bird? We can also, so augment is kind of like a nice basic, give me the predicted class, give me the probabilities. You also can use predict bird fit new bird data, and you can have a little more control here and say type conf int. Say we want confidence intervals. So we don't have this, this data anymore, but we do have for 95% confidence intervals, we have what's the lower confidence interval for that we see a bird, the upper confidence interval that we see a bird. So let's put all this together. So let's augment. So augment is a great thing to know how to use. Predict, of course, a great thing to know how to use. You can look up in the documentation all the different kinds of predictions you can do. And the great thing is they have all consistent in like inputs and outputs. Let's call this bird preds, like this. And let us now make a nice plot of this. So let's put the prediction on the x-axis, the bird on the y-axis, make color urban, rural, like so. And then let's put points on. And then this will be very similar to this plot that we made up here. Let's paste it. Copy paste, everyone's best friend. So now this is now a predicted probability of seeing a bird. All right, but not only do we have points, we have confidence intervals. So let's do it like this. AES x min equals pred lower bird x max pred upper bird, and then let's make these look pretty nice by my from my opinionated stance. Okay, what did I do? 0.2. Is that pretty good? Yeah, that's pretty good. Yeah, let's make them a little wider. Okay, that's pretty good. Okay, so these are now, from our model, the predicted probability of seeing a bird of these kinds in these places, urban and rural places. So we used our feature engineering, our modeling to be able to do this. Let's actually throw this all together. Let's call this P1. And let's call this one P2. And then let's actually, I am a huge fan of the patchwork package. And we can throw these together and see what we have here. Okay. This is pretty nice. So let's look at like a couple of these. So the superb fairy wren, on the left-hand side over here, we see what we observed how often did we, at all these different bird baths, did we see the superb fairy wren in urban areas, in rural areas, and how does in our model over here, what is the, oh shoot, I predicted, there we go. How often does the model predict that we will see it, and what are the confidence intervals, upper and lower confidence intervals here? And we see that we've got some pretty, we successfully modeled our data, which is always a good feeling. We're glad to be able to see this. And we can notice some things like the satin bowerbird, for whatever reason, we don't see a big difference between urban and rural areas. The Australian magpie, we don't see a difference. And things like the rainbow lorikeet and the noisy miner are more urban birds, and the superb fairy wren, and these three down here are more rural birds. All right, so during exploratory data analysis, we saw that there was those interactions between bird type and urban and rural status. We saw different kinds of birds in urban spots than rural spots, and then we were able to incorporate that information into our feature engineering recipe, our pre-processing recipe. It really helped our model, no surprise, right? Like, it really helped the kind of model results that we saw. And then we were able to fit our data, so fit our model to our data, and then predict on new data, either like the testing data or new data that we created from scratch. And then we were able to, get out those probabilities of seeing different kinds of birds in different kinds of spots. So I hope that this was helpful, and I'll see you next time.